So we'll start the first method to solve the system of linear equation using the Gauss elimination methods. So system of linear equation can be solved using Gauss elimination method. We are going to focus on only elimination method. We use a Gauss elimination method, and then LU factorization method. Actually we have the Doolittle, Cholesky, Kraut, Thomas. And then we are going to focus on Thomas algorithm, which is a generalization of Thomas method. Iterative method, we focus on the Gauss-Seidel, iterative methods. So system of linear equation. Linear because, you have here, let's say a11 x1, this is power 1, plus a12 x2 power 1 plus, until let's say a1n xn power 1. So xk is power, all the x variable x1 x2 until x power n are degree 1. So this is linear equation, then equal to b1. All the a11 a12 a1n b1 here are all the coefficient, or the mean the values of either integer or real number. So system, because you have more than one equation, so it becomes system, and this is a linear equation. So when you have more than one equation, this becomes system of linear equation. So second equation, let's say a21 x1 plus a22 x2 plus a2n xn equal to b2. The last equation, am1 x1 plus am2 x2 plus until amn xn equal to bm. So this is either written in equation form, or we can have have this form, or you can put in the matrix form ax equal to b, where from we have got up to m equation. You can put to the coefficient for a11 until amn can be collected as a matrix A. So a11 mean from first row, you just extract out each of the coefficient row by row. So this will be your matrix A. X is actually the vector x1 until xn that we are going to solve. So when you multiply back, using the matrix multiplication, you will get back the equation as what we hold on. And here, when you use back matrix multiplication, remember row time column, you will get, you have first row time, one column you get here, this one. So a11 multiply x1 plus a12 multiply x2, and then until the last one, a1n times xn, you get b1. So it will repeat for second row. Second row multiply this column, you get the b2. The last row multiply this vector x, you will get bm. Bm, the last row. So mean either is written in the equation form or put into the matrix form, or another one, augmented matrix form, where you have here, this is a matrix A. The vector x is not shown but separate by a vertical bar. This is a vector B. Vector B. And then to solve the system of linear equation is actually we are going to find what is the value of x1, x2 until xn that satisfy, when you plug in into your left hand side, it will satisfy the vector B, or the right hand side of the equations here. So this is the system of linear equation. Then we got three methods that we are going to solve today using the Gauss elimination method, Thomas algorithm, and Gauss-Seidel iterative method. Then for system of linear equation, we got either the solution is unique solution, mean only one solution that you can obtain, or infinite many solution, or no solution at all. Okay, and then okay, we'll focus on the first case only, which is unique solution. Okay, and the unique solution occurs if okay, metric A is actually squared metric and determinant of A cannot be equal to 0. Okay, so now we are focused on the Gauss elimination method to solve the system of linear equation. Okay, we'll focus, okay, start from the 3 by 3 system. Okay, and then Gauss elimination method is actually we have to reduce a metric A to upper triangular matrix. Okay, using suitable row operation. Then you solve, okay, using then you can solve back the x using back substitution technique. Okay, for example, so mean initially we have ax equal to b. Metric A have, okay, this is A, this is B. Metric A has to be reduced become upper triangular metric. Mean the lower part start, okay, lower part is actually you have the, okay, mean the, okay, the entry below the diagonal. This is the diagonal. Entry below diagonal all become zero entry, and then just left the entry, okay, start from diagonal and upper part. So this is what we call upper triangular system. When you reduce the metric A, so using suitable row operation, so okay, together the vector B will be changes also. That's why become f1 f2 until fn. Then you use back substitution because mean we start from the last equation. Okay, start from the last equation, then you can find, okay, your this xn minus 1 until x number 1. So far any questions here? Okay, if not, we focus on the case 3 by 3, okay, system. You have the a11 x1 plus a12 x2 plus a13 x3 equal to b1. Second equation, a21 x1 plus a22 x2 plus a23 x3 equal to b2. And then the third equation, a31 x1 plus a32 x2 plus a33 x3 equal to b3. Okay, or in the augmented metric form here, this is coefficient of metric A, coefficient for metric B. Then the Gauss elimination method, if the system is consists of 3 equations. Okay, then step 1, we do the row operation to reduce, okay, this one first, to reduce the entry A to 1 become 0, mean to eliminate, okay, the coefficient A to 1 from row 2. Okay, let's say this denote row 1, this is row 2, this is row 3. So we just use this operation, negative A21 divide A11. So mean you take the coefficient of k A21, negative A21 divide, okay, A11. This is constant. This is a constant value. Okay, multiply row 1 plus row 2. Okay, put into the new row 2. Mean after this operation, A21 will become 0. Cause, okay, and you see when in column 1, okay, this, okay, negative A21 divide A11, row 1, okay, when in column 1, row 1 value is actually, okay, A11, add up, row 2 value is actually A21. So you see, negative A21 plus A21, that's why you get 0. Then, okay, you put into the new row 2. So mean there's no changes on row 1, so you just copy down row 1. So this A13, this is B1, this entry becomes 0. Okay, and then you need to repeat for column 2, column 3. So negative A21, this is constant value. So in column 2, row 1 is A12. So you add up A22. Okay, what's the value? And then right here. Column 3, so in negative A21 divide A11. Okay, row 1, the value is A13. Row 2, the value is, okay, A23. So put out the value here, value here. and then repeat for column 4. So negative A21 divide A11. Column 4, okay, you have row 1 is B1, row 2 is B2. Okay, you get the value put up there. So after this row operation, A21 will become 0. And then, so the second step, we are going to eliminate the entry, the coefficient A31 become 0. B1, this entry becomes 0. So using the similar row operation, we have negative A31 divide A11. Okay, multiply row 1 plus row 3, it put into the new row 3. So in column 1, so you have negative A31 divide A11. Column 1, row 1 is A11, row 3 is A31. So you see negative A31 plus A31, you get 0. So mean this entry, you reduce it to 0. And then you repeat the process for column 2, column 3, column 4. If using calculator, then you have to calculate one by one. Okay, if you key in the formula in Excel, you can just copy it, drag the formula down. So it will be much faster and easier. Okay. So if you got question, you may interrupt me. After these two steps, A21, A31 becomes 0 because there's a changes on row 2, row 3. That's why there's a prime there. And then, our purpose is reduce it become upper triangular matrix, right? So mean we still need to eliminate A32 prime become 0. That's why we need the step 3. Step 3 to eliminate the A32 prime become 0. We want to make this entry become 0. Then the operation is negative A32 prime. Okay, you want to eliminate the entry below row 2, so you multiply mean negative A32 prime divide A22 prime. Okay, negative this one divide this one, multiply row 2 plus row 3 prime, because this you got changes R2 prime, this is R3 prime. So multiply row 2 prime plus R3 prime. Row 3 the second time of changes, that's why R3 double prime. So after step 3, we'll get upper triangular matrix. This is if you do it in calculator, we'll the row 2 prime we using the symbol D, and then row 3 prime using the symbol E. If this is using calculator. So after step 3, we get upper triangular matrix. Then we can use the backward substitution technique to obtain the solution for x1, x2, x3. In this form or here, your matrix A x equal to B. Then you use backward substitution, means start from the last row. So A33 double prime multiply x3 equal to B3 double prime. Then you can obtain x number 3. And then once you obtain the value of x number 3, you can obtain x2 from the second equation. A22 double prime multiply x2, because you take row. Take this row, multiply this column. 0 times x1 plus A22 prime multiply x2 plus A23 prime multiply x3 equal to B2 prime. And then plug in the x3 value. Then you can obtain x2. You can obtain x2. Which is your B2 prime minus A23 prime x3 divided by A22 prime. Lastly, plug in x2, x3 value into first equation, then you can obtain x1 value. A11 x1 plus A12 x2 plus A13 x3 equal to B1. So plug in the x3 value, the x2 value, then you can obtain x number 1. mean you want to solve x1. So, okay, these two terms you bring to right hand side. So x1 is b1 minus a12 x2 minus a13 x3 divided by a11. So this is so-called the backward substitution. We got someone just join here. Okay, we are going to solve this example one. This is a x equal to b using Gauss elimination method. Okay, so first of all, first step, okay, I will transfer everything to Microsoft Excel. So and show first. Do I want to do this? Okay, this is the 3 by 3 system that we're going to solve using Gauss elimination method. Okay, so I will step one. Step one. Okay, put out the formula for step one is actually we want to eliminate this one. These two become 0. Okay, the operation is negative. Okay, I copied the formula here. Yeah. Negative a21 divide a11 multiply row 1 plus row 2 put into the new row 2. Okay, so key in the put it here 2 negative 4 negative 1 9 okay. So this is our matrix A, this is a vector B. So first step, we want to eliminate this entry. A21 becomes 0 using the row operation, which is negative A21 divide A11 multiply row 1. Okay, so this one is the same. I can select like this. Okay. First row, there's no changes. So first row, you can copy it down. 9 here. There's no changes on first row. So copy it down first row. Okay, this is initial R1. Okay, R2, R3. So there's no changes on row 1. Just put R1. Okay, there's a changes on row 2. So this is what we denote as R2 prime. Okay, to eliminate the cell A21, we use this is a row operation, mean the operation apply to the whole row 2. Okay, to key in the formula, as I said, A21 divide A11 is constant, so it have negative. So A21 is this cell, but it's constant value. In Excel, you have to put dollar front and back. So the dollar in front of H means fix the column H. Okay, dollar in front of 3, fix column 3. So this is how we define constant in Excel. So that when you copy it, the formula will always maintain H3. And then division is backslash, divide by A11. This is A11. So this is also constant. So you put dollar front and back. So I repeat one more time, okay? To get, I think just now, again, pause it. Okay, the value is pause. So manually, if you use this operation, negative A21 divide A11, so 2, negative 2 divide 2, the answer is negative 1. So in column 1, okay, column 1, row 1 is 2, row 2 is 2. So negative 2 plus 2, you get 0. Okay, you should get 0. Okay, and then column 2, okay, wait here, I show the, okay, then if we key in Excel, to key in any formula in Excel, so equal, so negative, click A21 divide A11, then because I want the constant value, so multiply, okay, multiply row 2, multiply row 1, row 1 here, plus row 2. Okay, but this is constant, A21, okay, this one is constant. So you have dollar front and dollar at the back. So you get 0. Tally with your manual calculation. Okay, but if you use Excel, it's very fast. If the formula is correct, when you copy it, okay, shortcut for you to copy. Okay, if you cannot, you just click here, Control C, go here, Control V, Control V, Control V. Okay, or shortcut, point to the right bottom cell. When you get the little plus, drag it. Done. So if you calculate manually, then okay, the coefficient for negative A21 divide A11 is negative. Column 2, row 1 is negative 4, row 2 is negative 2. So this is positive 4 minus 2. The answer is 2. Column 3, row 1 value is negative 1, so negative 9, negative 1, positive 1. Row 2 value is negative 5, so 1 minus 5, negative 4. Okay, column 3, column 4, so negative times 9 minus 8, plus 8, sorry. This is plus 8 because negative, okay, this one negative, row 1 is 9, so negative 9 plus 8. So you get negative 1. So this is manually, this is using Microsoft Excel. Okay, later on, step 2. Step 2, we are going to eliminate, okay, this one. Okay, using the, okay, row operation. I put it, step 2. Here. Negative A31 divide A11. So you key in here, negative. So A31 is here, divide A11. So remember, this is constant value. Then put dollar in front, okay, and back at your, okay, column label. Then multiply row 1 plus row 3. Okay, and then just copy it. So after 2 steps, okay, after 2 steps, we eliminate the cell A21, A31 become 0. So this is so-called the R3 prime. Then the purpose, okay, using Gauss elimination method is to reduce it become upper triangular matrix. Hence, you need the step number 3. Okay, step 3. Okay, this formula. Okay, step 3. We are going to eliminate this one. Okay, step 3. We want to make this cell become 0. So now there's no more changes on R1 and R2 prime. Then you may, okay, copy it down. This is 2, negative 4, negative 1, 9. Second row is 0, 2, negative 4, negative 1. Okay, no more changes on R1 and R2. We are going to change, okay, R3 prime using, okay, the formula is, okay, this one, there's, okay, this cell is actually, if you apply the formula here, okay, or here, you put it here, later you can copy left and right, doesn't matter. Yep, negative A32, this cell. I think because of when I highlight it, negative A32 here, divide, okay, A32 prime is from the R3 prime. A32 divide A22, okay, and this is constant. Don't forget this one is constant. Okay, if you don't want to put the, okay, the dollar front and dollar back, you may key in the value. Okay, put up the value, mean, okay, negative and then divide by negative 5 over 2. But if you put out, okay, the, like this one will be more flexible. So mean next time you can change any, okay, A and B, the formula still valid and the solution will be okay, automatically out. Mean, okay, if you put like this one will be more general. Instead of you key in, okay, A21 is 2, A11 is 2. Okay, and then multiply row 2, okay, sorry, row 3, sorry, row 2, multiply row 2 plus row 3. You see, you can copy it left, also 0, copy it to the right. So here, multiply, okay, R2 prime plus R3 prime put into the latest R3 prime. So this is 2 time changes. This is R3 prime. R1, there's no changes at all. R1, so R2, there's 1 time changes on row 2. So this R1, R2 prime, R3 double prime. So now this one become upper triangular matrix. It become upper triangular matrix like this. So after 3 steps, okay, this one is the result of step 1. I put it here. Result step 1, result of step 2, result of step 3. Okay, so after 3 steps, you get the upper triangular matrix, and then to get the what's the x, y, z, okay, you may need the, I put it here. This is z, this is the y, this is the x. Okay, you may need the using backward substitution technique. Start from the last, okay, the last equation. You got negative 12.5, okay, z equal to 20. Hence the z is actually 20 divided by negative 12.5, like this. Mean, okay, you start from the last row, the last row. this, you got negative 12.5 z equal to 20. So z will be 20 divide negative 12.5. That's what I key in here. Take this one, divide here. Okay, and then start from the second equation. You can calculate for your y. Okay, y will be actually, this one is actually 2y minus 4z equal to negative 1. Okay, and before I key in, okay, write down for you to see. Okay, from the second equation, you have 2y minus 4z equal to negative 1. Hence, the y will be, okay, negative 1 plus 4z divide 2. Okay, so you have, so you just key in the formula into Excel. This is your negative 1, and then minus, okay, minus, okay, uh, this is minus this one time z. Okay, I put minus, and then minus with the value is negative 4, so this become positive 4 times z. Close the bracket, divide by 2 is a coefficient here. So if you put out general formula, later if you change the, okay, metric A and B, everything is automatically calculated. Your y. And then later on the x. Okay, x is actually, okay, from the first row, you have 2x minus 4y minus z equal 9. You want to solve for x. So x is actually 9 plus 4y plus z divided by 2. Okay. Then you put up here. This is 9 here minus, okay, this one time y. Then minus, okay, here multiply z divide these two. Okay, and then after you obtain the value, you can, okay, use back inverse metric method to check whether your answer is, okay, correct. Checking using, let's say, checking using okay, inverse metric method. I want to get the x, y, z. Okay, remember, okay, we have, we have the ax equal to b. Okay, the solution is unique if the determinant of a is not 0. Then there exists a inverse metric A. Then you can use the inverse metric A to obtain the metric vector x, which is the A inverse multiplied B. So this, using the inverse metric method, that is the okay, exact method. Okay, and then the Gauss elimination method here is actually the approximate method. So we want to get the vector x, which consists of x, y, z. So it's a vector 3 cell. You select 3 cell. For metric multiplication is MMU ULT, that you have, okay, use it in the solving the nonlinear system by Newton's methods. Okay, array 1 is an inverse metric A. So M inverse, okay, metric A, select your metric A here. Okay, so for any, okay, function in Excel, open close bracket, so comma, okay, this is your vector B, then Control Shift Enter. So you see we obtain, so this is using inverse metric method, and then this is using Gauss elimination methods. Okay, second example, we solve the 4 by 4 system, but this is actually 3 diagonal metric where we can later on solve it using Thomas algorithm. Okay, this one can also solve it using Thomas algorithm. Okay, so this one, is it already in already in the upper triangular matrix? Okay, we are going to solve using the, again, only Gauss elimination method. Okay, this entry is 0, this is 0, this one is 0. Okay, but to get the upper triangular matrix, okay, start from diagonal x1, mean this one, mean the diagonal here, x1, 4x2, 7x3, 11x4. So the entry below the diagonal entry must be 0. Mean we have to eliminate 3x1 becomes 0, 6x2 becomes 0, 10x3 becomes 0. Then we get upper triangular matrix, and then we can solve it using backward substitution technique. Okay, so we are going to quickly solve this one using Microsoft Excel. Okay, put up here, put here. So we key in the, okay, system 12001. Okay, this is metric A, this is a vector B. Second row 3 4 5 0 0. Third row 0 6 7 8 2. Third row 0 0 10 11 3. Okay, so now we want to eliminate this cell, this one, this one. So you got three elimination step. So there's no changes on row 1. So I copy down 1 2 0 0 1. So there's no changes on row 1. I'm going, this is inertia, this is row 1. Okay, you see, I just type R1 and copy down, become R2, R3, R4. This is what so-called relative row. Or you copy it, okay, to the next, you see, same. Okay, okay, so I'm going to eliminate the A21 becomes 0. So the operations, let me write down the operation. To eliminate this cell becomes 0, your step should be put that here. And step 1 should be negative. You want this cell becomes 0. So we take this cell negative A21. Okay, this is below the, okay, diagonal value of A11. So divide by A11. So multiply row 1. Why multiply row 1? So that you see A11, when column 1, so R1 will be A11, so cancel each other. So add up with row 2. Row 2, which is A21. That's why this entry will become 0. So the formula is negative A21 divide A11 multiply row 1 plus row 2 for step number 1. Okay, so step 1 is just plug in. So negative, so click A21 divide A11. Okay, and don't forget the coefficient is constant. Then you multiply row 1 plus row 2. Then you enter. Okay, and just now, the sheet that you have developed, you can try to change to any system. Okay, the formula should be automatically out. You can change your metric A, metric B, because this is all consists of formula. So the formula will be automatic out, including okay, your inverse metric method. Okay, but for the this 4 by 4, okay, because this A31 mean this one A31, A41, A3, A42 already 0. Okay, that's why if we put up other 4 by 4 system that consists value, so cannot unless you put it exactly these three diagonal matrix. Okay, so this entry is 0. Now we are going to eliminate 6 become 0. Okay, 6 below the column 2. So row 2, the formula. Okay, we want this entry become 0. This is the cell third row second column, so negative A32 below column 2 mean the pivot at okay, A22, so divide by A22, so multiply row 2 plus row 3. Okay, pivot is from row 2 column 2, so multiply row 2, so A32 from row 3. So you see divide A1 multiply by row 1, take 1 and then take add up row 2. So that is the second formula. Okay, so I can copy it here. Negative, this is A32 divide A22 multiply row 2 plus row 3. Okay, but don't forget, okay, constant you have to put dollar in front and at the back. Okay, then you can copy it left. Mm. On suppose you, let's see, copy it left, I should get this one not 0. Okay, I should get the latest row 2. Okay, the mistake is I should get the latest row 2, not the, mean I should get the latest, okay, row 2 is here. Mean this one, otherwise this one you won't get 0. Mean here, row 2, I should get the latest here. See, row 3, okay, A32 here, and then A22 is the latest, and then plus C, row 2, row 2, row 2, 12 become here 17. Mm. So now correct. Here, this one, A32, A22, A22, make sure take the latest. Okay. If not, this entry you won't get 0 if you take back this row 2. The mistake is here, negative A32, A32, still the old one. Yeah, when I highlight it, this one I have to delete first. Okay, this one, negative A32, still O, A22, you got the latest. And then put constant, multiply row 2, row 2 take the latest row 2, row 3, okay, still the old one. So when you copy it to the left, okay, this cell must be 0, otherwise you won't get upper triangular matrix. I mean, this is a R2 prime. If you take the O row 2, this one still consists of, okay, 3. That's why this entry you won't get 0. And the value here will be wrong also, because you take I think this one 50, yeah. So this is a step 2, row 2, okay, and the A22 prime take the latest. Okay, and then step 3, we are no longer eliminate this one. We have to eliminate the latest system, this one, 22. So then the step 3, the operation is we are going to eliminate this one, becomes 0. So this is the cell, okay, row 3, column 2. So negative A32 prime. Okay, we want to, what is that? A bit confused already. Oh, sorry, we still correct, make this one 0, but the A32 prime, make sure take the latest one. We want to make 32. So row 1, sorry, row 4 3. So the formula is negative A number 4, column 3, divide, okay, the pivot, this is A33 prime. So multiply row 3 plus row 4. Okay, can you understand how I get the formula? Later on, you want to eliminate this 10 here, become 0. This is okay. So the formula negative, take this cell value, negative A43, divide A33, take the latest, don't take 7, take the 22, take the latest. So R3 will be R3 prime, R3 prime. So this is the R3 prime already. This is a R2 prime. Then you key in the formula, negative A, yeah, because when I circle it, I cannot click. So you have negative, this cell A43, divide, okay, then A33, the latest one. Then constant it, okay, multiply row 3, okay, column 3, row 3 is here, plus, okay, row 4, still the old one. Okay, enter. Wait, will not get 0, so something wrong. A43 is here, D14, divide A33, D18, multiply D18. Oh, I didn't put negative. So now 0. Right. So to check, okay, left, okay, the left side must be already reduced to 0. If not 0, because maybe here A33 you take the O1, row 3 also you take the O1. Okay, so after 3 step, we have reduced it to upper triangular matrix, because this is diagonal, 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 diagonal. So after 3 step here, we get the, okay, upper triangular matrix. This is already upper triangular matrix. See that? This is upper triangular matrix. Then you can solve, okay, using, then you can solve using backward substitution technique. Backward substitution technique. So what is the initially is what? x1, x2, x3, x4. So I put it x1, x2, x3, x4. So start from row number 4. 7.36364 x4 equal to 6.181 So x4 will be your b number 4 divide, okay, coefficient of x4. Okay, and then x3 using the backward substitution technique will be your b3. Okay, minus you take this one. This is 0 x1 plus 0 x2, okay, plus 22 x3. So you bring to the other side will be minus 22. 22 is d18. So multiply x number oh sorry, uh, not minus this one, minus this, minus 22 x3. We are going to solve x3, so later on we divide by 22. So okay, plus 8 x4. So bring to the other side become minus 8. 8 is E18, so you multiply x4, then you divide by coefficient of x number 3, which is 22. So you get the x number 3, and then x2, using the similar technique, you have b3 minus, okay, this is we are going to solve x2, so divide by here. So this coefficient, okay, time x3 minus, okay, this coefficient time x number 4 divide this coefficient. Okay, x1 will be b1 minus, okay, the coefficient of x2 minus coefficient of x2 time x2 minus coefficient of x number 3 multiply x3 minus coefficient of x number 4 time x4, okay, divide by coefficient of, okay, x1. Okay, this is using backward substitution technique. Okay, you may check using, in case you got calculation mistake, check it using inverse metric method. Okay, so MMULT, M inverse, okay, taking the original matrix A. So M inverse, find the A inverse, multiply with vector B, and then don't forget to press Ctrl Shift Enter. So we get the exactly the same answer. So this is using Gauss elimination method. This is using inverse matrix method.